For curved lines, determining the gradient using a graph is very difficult. So algebra is the preferred method for determining the gradient at a specific point, and this is known as differentiation. In order to use this method, you must know the equation of the line. The general rule for equations with this form is y equals ax to the power of n plus c becomes dy by dx equals nacx n minus 1 using differentiation. In this equation, c is a constant, but you're differentiating with respect to x, which means anything without an x in it doesn't show up in the final differentiated equation, which is why there is no constant on this side. We're going to look at this differentiation using some examples. First example is y equals x squared. In this example, a equals 1 and n equals 2. So using our general equation here, dy by dx equals 1 times 2x to the power of 2 minus 1. This can also be written as 2x to the power of 1. Anything to the power of 1 is just written without the 1 there. You don't need it, it's implied. So 2x is the same thing as 2x to the power of 1. Our next example is y equals 2x cubed, 2x to the power of 3. A equals 2 and n equals 3. So using our general equation again, dy by dx equals 3 times 2x to the power of 3 minus 1. 3 times 2 is 6, and 3 minus 1 is 2. So our final value is 6x squared. Our next equation is y equals 5x to the power of 4 plus 7. A is 5, n is 4, and using our general formula again, dy by dx equals 4 times 5x to the power of 4 minus 1. As I said before, the constant doesn't show up on the other side because it's not got an x value, so it just doesn't cross over. 4 times 5 is 20, and 4 minus 1 is 3. So 20x to the power of 3. The next example is y equals 4x to the minus 3 plus 2. Just because it's a minus number doesn't make any difference, you just do it exactly the same way. So a is 4, n is minus 3, dy by dx equals minus 3 times 4 x to the power of minus 3 minus 1. Once again, the constant doesn't come across. Minus 3 times 4 is minus 12, and minus 3 minus 1 is minus 4. So it's minus 12x to the power of minus 4. Our final example is y equals 4x to the power of 3 over 2 plus 7. It's a fraction this time, our power, but that once again doesn't make any difference, you just do it exactly the same way. A equals 4, x equals 3 over 2, so dy by dx equals 3 over 2 times 4 x to the power of 3 over 2 minus 1. 3 over 2 by 4 is 6. 3 over 2 minus 1 is a half. So we have 6x to the power of a half. anything to the power of a half is just a square root, which means that our final value can be written as 6 square root x.